Video number 233, comparing and rounding decimals. We have 8/10 versus 9/10. That's pretty obvious there. Obviously, 9/10 is larger. Next one, 39/100ths versus 3/10. That's a little bit tougher to understand, but I think we could all recognize that 39/100ths is larger because 39/100ths means you have 3/10 and then 9/100ths. So this does not have the 9/100ths. This has, what, 9 more pennies than this. Then the third one, 30/100ths versus 3/10. Those are going to be equal. And then this last one's rather interesting. You have 97 10,000ths versus 201 10,000ths. Well, when you say it the way I've just pronounced it, it's obvious that the 201 10,000ths is more than 97 10,000ths. But if you're looking at this problem and just glancing at the numbers, you may just pick the 97 by accident, thinking that the 97 is larger when it is not. So there's the comparisons. There's two ways of saying this. Either 8/10 is less than 9/10, or 9/10 is greater than 8/10. There's two ways of saying this. You can read it from left to right or right to left. And that's how that would shake down. Next one, round to the nearest whole number. So we have 5 and 7,393 10,000ths. We're going to round that up to 6 because we look at the next two numbers and we see that's a 73% of another number. So you have 5 and 73% of another number, so therefore 6. You could use the next one number, 7/10 of another whole number, and get up to a 6 that way. This is going to go to 22, and the last one is going to go up to a 40. So because we can't round a 5 up to, the 5's not going to round the 9 up. First of all, this is a 50. Halfway rounds up. That's just the way it goes. Half rounds up. So halfway to another whole number rounds the 9 up to a 10, which you cannot do a 10, so we just round the 39 up to a 40. All right. Next one, we have use long division, then round to the nearest thousandth. Well, 3 divided by 14, we definitely cannot divide 14 into 3. So we can get a decimal version of the story, and we would just change the 3 to 3.000. Now, we would use 3 zeros here because we do want to find out what the third decimal would be in order for us to successfully round to the nearest 100th. So 14 goes into 30 twice. Even though this is 3.0, we're going to think of this as 30 so that we can perform the division operation. 14 does not go into 3, so you could put a 0 there arguably. 14 goes into 30 twice. So we put a 2 there and just pretend as if the decimal's not there, and we would just put it in 2 places. There's the 3.0, so we put the decimal up here. All right, and everything would just act the way we would when we do long division. So 14 goes into 30 twice. You multiply it down to get 28, subtract to get a 2, bring down this 0. 14 goes into 20 once, times 14, subtract, bring down the 6. I'm sorry, subtract to get 6, bring down the 0. 14 goes into 60 only 4 times. Therefore, this rounds off to 21 100ths. Next one. Here's an interesting one. You're getting all 2's. 20 divided by 9, you get all 2's there. And again, what you would do, because we do want to round to the nearest 100th, we would just go ahead and use a bunch of zeros after the decimal place. So therefore, 9 goes into 20 twice. Get down to an 18, subtract to get 2, bring down the 0. 9 goes into 20 twice. 18, subtract 2, bring down the next 0. Just keep getting a bunch of 2's, therefore we get 2.22 or 2 and 22 100ths. Last one, 5 divided by 3. Well, in this case, 3 goes into 5 once, times, then 1 times 3 gives us 3. Subtract, you get 2. Bring down the 0. Subtract, you get 2. Bring down the 0. 3 goes into 26 times. 18, subtract. You keep getting a bunch of 6's. Therefore, we get 1 and 67 100ths, as the next percentage would be 66%. So therefore, that's more than a half. So therefore, bam, 1 and 67 100ths.